Okay. Assalamualaikum and good morning.
Waalaikumsalam, Doktor.
Okay. Okay.
Sana Doktor.
Good morning, Doctor.
Okay. Okay. So clear. All of you can hear me.
Yes, Doktor.
Okay. Very good. Okay. So this is our first lecture for STKM 1222. Last week it was a public holiday, so we do not have lecture. Okay. So I don't think that you have met me before. Okay, so a little bit of my self introduction. And anyway, just to inform you that I'm recording this session, and then I will post it on YouTube, so that if any of you wants to refer to it later, then you can always access it on YouTube. Okay. 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 Okay, can you see it?
Yes, Doktor.
Okay. Okay, so my name is Muhammad Yusof Maskat. Okay. I've been a lecturer here since the year 2000. Okay, in UKM. Going to retire soon. Okay. Okay, so my field of expertise is in food processing. And there you can see my handphone number. Okay, if you want to ask me anything, you can always WhatsApp me. Okay, or if you prefer to send me an email, so that is my email address. Okay, and my office is at Bilik Pensyarah 7. That it means that it is a lecturer room 7. Okay, at the Bangunan Makmal Tambahan FST. So, okay, I just put it there because I know all of you are at home right now, I think. Okay, and but anyway, if you ever come, if you ever have this in UKM in the future, then that is my room, so you can see me there. Okay. Okay, so that is my self introduction. Okay. So let's go straight to our lecture. Okay, I think the background information of this course has been presented by Dr. Fatima. Okay, so I will not repeat it again. Okay, so we'll go straight to our lecture. Okay, for my part, okay, okay, so I've uploaded the notes on UKM Folio. Are any of you do any of you have problems accessing UKM Folio?
No, Doktor.
No, Doctor.
Semua okay. Okay. Okay, good. So you can download it from UKM Folio. Okay. Okay, so my part will be about food preservation using low temperature. Okay, so for this part, we will have one quiz, okay, which is going to be next week. Okay, so one quiz, a short quiz. Okay, and then after that, your mid-semester exam. So for your mid-semester exam, which will be after your mid-sem break. Okay, so now this week is week 5. Okay, so week 5. So we have another 2 weeks, okay, up to week 7, and then you will have your mid-semester break. And then for the mid-semester exam for food preservation for this course, we will have it not on our lecture session, because other lecturers will come in. Okay, will use that session for their lecture for the rest of this course. Okay, so we will decide when we will have the mid-semester exam. Usually, I would prefer it to be during the using the lecture period. Okay, but because last week we missed 1 week, okay, due to the public holiday. So we won't be having, so we are short of 1 week. Okay, so maybe going to be at night, or we'll discuss that later. Okay, so for the mid-semester exam, it will be, it will include my part and also the part of Dr. Fatima. Okay, so that will be 35% of your final mark. Okay, so we already have 2 quizzes under Dr. Fatima, so 5% each, so that will be 10%. And from me, you will have, I will be giving you another quiz, that is another 5%. So in total, the quizzes will account for 15% of your total marks. And for the mid-semester exam, another 35%. So that will be 50% in total. Okay, so that will cover the first half of the semester. Okay, and whatever that we have discussed, it will not be in your final exam. Sorry, you do not have a final exam. Okay, in your final, you won't have a final exam. Okay, so it will be on a continuous assessment under Dr. Saiful and also Dr. Asnaniza. Okay. Okay, any questions? Okay, so if everybody is clear regarding the marking, okay, so let's start. Okay, our lecture. Sorry. Okay. Okay, so food preservation using low temperature. Okay. So I think now you understand what is the purpose of food preservation that has been discussed by Dr. Fatima. Okay, so it is important. Food preservation is a very important aspect. Okay, when it comes to food production. Okay, so there are many strategies, okay, that we can use, okay, for food preservation. Basically, what we want to do is to prolong the shelf life of the product, because by prolonging the shelf life of the product, then we will be able to offer the product to the consumers for uh, a longer period of time. Okay, and also it will also increase the confidence of the consumers to the products. Okay, for example, if you were to go to the supermarkets or the hypermarkets, and then you look at the product and it only has 2 weeks time before its expiry date, and another product has like another 6 months of time before its expiry date, then of course we will choose the one that has a longer shelf life. Okay, so food preservation plays a role not only on the safety aspects but also on the quality aspect of food products. Okay. Okay, so what are the food strategies, examples? Okay, so examples of the food preservation strategies are like reduction of water availability. So, for example, drying. Okay, and then we also have low temperature. For example, chilling and also freezing. What is chilling and freezing? Chilling is the reduction of the lowering of temperature, okay, of the product storage, okay, but still above the freezing point of water. Okay, so the freezing point of water, the freezing point of pure water is at 0 degrees C. Okay, so when we talk about chilling, then we lower the temperature, but it does not reach to the point of the freezing point of water, meaning that water will still be in its liquid state. Okay, freezing is when we lower the temperature but more extreme. Okay, where we lower it below the freezing point of water. Okay, so when freezing, then water is in the solid state. Water inside the food products, because food products contain a lot of water. Okay, so it is in the solid state. Okay, so that is the two different the difference between chilling and freezing. To show you the difference, okay, in a clearer manner, okay, if we were to open our refrigerator, okay, there will be a section where we put all the food stuff, the fruits, the vegetables, and then anything, okay, the bigger space. So that is the chilling space. And then another compartment where we make ice, okay, we make ice cubes, or we put in our frozen foods. So that is freezing. So you can see that freezing, okay, the food product is very hard, okay, it's in a very solid condition, whereas chilling, it is still in its actual state, okay. So that is the difference. Okay, then apart from that, there are chemicals. This also you have discussed with Dr. Fatima, okay, and there are others. Okay, these are just examples. Okay, food system, threats to the food system. Okay, why are we? What is the purpose of the objective of preserving foods? How do we preserve foods? Okay, so when we talk about food systems, okay, what is a food system? A food system is defined by its boundaries. Okay, if you were to talk about a can of sardines, for example, so that is a food system. And when we talk about a food system regarding a can of sardines, then meaning that the food is the sardines in tomato sauce, for example, and it is being defined by the boundaries. The boundaries is the can. Okay, so that is a food system. Okay, if we have, for example, like a bottle of milk, for example, okay, so that is also a food system where the boundaries are the bottle itself, and the food system, the food is the milk itself. Okay, so when we talk about food systems, it is a food with a clear boundary. Okay, and then dynamic systems versus static systems. Okay, when we say dynamic, meaning that it changes. It changes. So dynamic systems are changing systems. Static systems are systems that basically do not change. Okay, so are food dynamic systems or static systems? If you were to take a can of sardines, for example, or a package of a pack of food, okay, and then nasi lemak, for example, or burgers, for example, okay, and then we put it on the table, okay, in the morning, okay, and then in the afternoon or in the evening, okay, the food will still be there, right? Okay, the food will still be there, okay. Okay, so it seems like it is a static system because it did not move. Okay, it did not change. But in actuality, it has changed. If you were to put it in the morning, what happens in the evening? It has already spoiled. Okay, so meaning that changes are happening, even though translocationally, okay, it does not change. Okay, translocation meaning that the location. Okay, it does not change, but inside it, okay, biologically, chemically, microbiologically, it changes from being able to be consumed to a spoiled state. Okay, so food is a dynamic system. So even though it doesn't translocationally move around or changes, but still it is a dynamic system. Okay. And then these changes, sometimes they are natural, sometimes they are induced. Okay, for example, like natural changes, like bananas. Okay, it will ripen over time. Okay, from hard and green in color to yellow and soft in texture. Okay, so that is a natural ripening process. Induce, okay, the same process, the same banana, okay, we put in ethylene oxide, then we induce it to ripen. Okay, so there are natural changes and also induced changes to food systems. Okay, Okay, the effects. Okay, what are the effects of threats to the food system? So usually it will result in food spoilage. Okay, and also increased damage, rate of damage or degradation of the food. Okay. Okay. Reduction or loss of features, okay, ideal to the food, even though when we talk about increased, okay, rate of degradation. Let me change this. Rate of degradation, okay, and then, okay, reduction and loss of features of ideal features of the food, sorry. Okay. Okay. So, degradation meaning that the food becomes spoiled. Okay, we cannot use it anymore. Reduction and loss of ideal features of the food, meaning that we can still, the food is still safe, we can use it, but we don't like it. Okay, we don't like it. Okay, so that is the reduction and loss of ideal features. What are the ideal features? Ideal features are being defined by the consumers. Okay, for example, if we have a bottle of fruit juice. Okay, a bottle of fruit juice. It is an orange juice and it has its peel inside it. Okay, so but after some time there is a precipitation, little bit mendap. Okay, precipitation. Okay, so when precipitation occurs, then we can see that it will have like two layers. Okay, it will have two layers in the bottom. So that is not ideal. Consumers may perceive it as being spoiled, but actually it is not spoiled because it is just a physical change. Okay, so microbiologically it is still safe. Okay, but that is an example of loss of ideal features. Okay, and then quality and safety are affected. Okay, when we talk about food preservation, these two aspects are very important. Okay, so when we talk about preservation, immediately, okay, I want to stress this uh, uh, a lot. Okay, so I want to really stress this, okay, that when we talk about preservation, then these two aspects has to be there. Okay, when we talk about safety, safety is something which is defined by science. Okay, it is regarding the relationship between consumer and health. Okay, that is safety. Consumer and health. Okay, so that is safety. So anything, it doesn't necessarily means death, but okay, anything that causes discomfort to the consumers, that is a safety issue. Consumers' health, okay, that is a safety issue. Nausea, diarrhea, vomiting, all of those, okay, even though the consumer did not die or pass away, but still it is a safety issue. Okay, and then quality. Okay, quality is not related to health, but rather it is related to the preference of the consumers. Okay, for example, like if we want, the consumers prefer wants to buy, or we want to buy a bottle of soy sauce. Okay, and then we go to the stores, and then we see that the color of the soy sauce is blue. Okay, what will be our reaction? Okay, we will stop for a while and think, right? Okay, because of course we blue is a beautiful color. Okay, but the common color of soy sauce is dark, right? So when we go to the store to buy a soy sauce, a bottle of soy sauce, then our expectation and our acceptance is that soy sauce has to be dark in color. So when it is blue, then it is the consumers will not feel comfortable. Okay, so even though there is nothing wrong between blue and dark, okay, but it is being defined by the preference of the consumers. Okay, so that is quality. Okay, taste, for example, and then the color, and then the viscosity. Okay, all of those are quality aspects. Okay, it does not affect, okay, the health of the consumers, but it is against it is something that uh, depends on the preference of the consumers. Okay. If any of you want to ask questions, okay, you can always interrupt me, okay, and ask the questions. Okay, so let's look at this. Okay. Okay. So this diagram. Okay. So for example, we have this food system. Okay, in the middle. So in our food system, okay, usually we will have these components. We have water, carbohydrate, okay, CHO is carbohydrate, and then protein, fat, vitamin, minerals, etc., etc. Okay, so this is our food system. Okay, so this food system will always be under threat. Okay, will always be under threat. Okay, first, for example, physical threats. Okay, physical threats are like, for example, light. Okay, heat. Okay, heat. Okay, and then force. Okay, so certain vitamins, like, okay, certain vitamins cannot be exposed to light, then they will degrade. Okay, and certain food products, okay, cannot experience high heat. For example, ice cream. Okay, so those are the threat factors. Okay, and then force. For example, certain products cannot endure high force. Okay, for example, like biscuits, because they are crunchy, so we do not want it. Uh, if there is a lot of force, then it will break the biscuits. Okay, so those are examples of physical threats to foods. Okay, and then there are also chemical threats. Okay, chemical external factors. Okay, chemical external factors. For example, like rancidity. Okay, okay, uh, chemical external factor reaction. Okay, reaction. Okay, and then you also have chemical internal factor reactions. Okay. 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 So external factor reaction, that is something which is which is which involves external factors. Okay. For example, like rancidity. Okay. So rancidity, kepengikan. Okay. It is caused by oxidation. Okay. So when the oxygen is out of the food system. Okay, it's outside of the food system. So when the food system is being exposed to oxygen, then it becomes rancid. Banana chips, for example, keripik pisang. Okay, so when it is stored, then because keripik pisang or banana chips are fried products, so it contains a lot of oil. So oil will react with oxygen and develop a rancid flavor. Okay, rasa kepengikan. Okay, so that is an example of a chemical external factor reaction. Okay, then there is also a chemical internal factor reaction. Okay, that it happens inside the food product itself. We have discussed it just now. Among the example is like the ripening or the aging of fruits. Okay, bananas, for example. Okay, aging is part of the ripening process. Okay, so from green in color and hard in texture to yellow in color and soft in texture. Okay, so that is chemistry. And also there is biology. Okay, so we have microorganisms and then we have enzymatic reactions. Okay, so because these two are the most, there are others, macro organisms, rats, cockroaches, etc. Okay, but these are the two most important threat factors to food. Okay, microorganism is number one. Okay, and then enzymatic. Okay, enzymatic reactions. So enzymatic reactions will affect the aging process, oxidation, for example, enzymatic browning, polyphenol oxidase. Okay, and then we also have microorganisms. This is the most important. Okay, because the majority of food spoilage is due to the growth of microorganisms. Okay, so it will cause damage. Okay, so when we understand this, okay, because we have the food system and we have all these external threat factors trying to degrade our food system. So what is our approach to food preservation? Then what we do is to stop this and stop this and stop this, and our food will have a longer shelf life. So that is the approach. Okay, in food preservation we do not have a standard approach. Okay, it is different in chemistry. For example, if you want to measure moisture content, then there is a standard way of doing it. Okay, so in food preservation there is no standard way of preserving foods, because foods are very heterogeneous, meaning that foods are so very different, okay, from one another. Okay, so all of this, okay, are just basic stuff. They also, because foods also contain other components. So what is the approach of food preservation? First of all, we have to understand our food products. Okay, we have to understand our food product, because different food products will contain different amounts of all of this. Okay, and that will affect, okay, what threat factors will play into in degrading the food products. Okay, and then based on this, okay, we determine what are the physical, chemical, and biological threat factors. Okay, so because different components, okay, composition of food will have different threat factors. For example, if you have biscuits, okay, okay, it is very dry, so one of the threat factors is, for example, breakage, or physical, chemical oxidation, because biscuits also contain oil. Okay, and then of course microorganisms, because it has very low water activity or moisture content, because it has been baked. Okay, and then so microorganisms, what is important will be molds, fungi and molds. Okay, as opposed to viruses or bacteria. Okay, so the approach is, first of all, understand and know your food products. Okay, then based on that, we determine the threat factors. Okay, determine the threat factors and then try to stop the threat factors, okay, from affecting our food system. Okay, so that is the basic approach of food preservation. Okay, so for this topic, we will talk about the use of low temperature. Okay, use of low temperature, okay, on for food preservation. Okay, so as I mentioned just now, the approach of preserving foods is to stop the threat factors. So if you can, in general, if you can stop the threat factors, then the food will have a longer shelf life. Okay. Okay. So in this part of the course, we will talk about using low temperature to prolong the shelf life of food for food preservation. Okay. So first of all, we need to know, okay, what are the effects of low temperature on the threat factors. Okay, so then we will understand why and how low temperature prolongs the shelf life of food products. Okay, first of all, okay, among the main factors is chemical reaction. Okay, so we have discussed this. Okay, so we have discussed this just now. Okay. Okay, so we have discussed this just now. Okay. Okay, so chemical reaction rate. So chemical reaction, for example, oxidation, okay, hydrolysis, all of this happens in food systems. Okay, so but most reaction rates, okay, depend on temperature. Okay, because these reactions, okay, they need energy. So among the most common source of energy is temperature. Okay, so low temperature, so chemical reactions will be slower. Okay, the higher the temperature, so the reaction rate will be higher. Okay, so that is in general. But then, how do we understand? How do we know that if we have lower temperature, then how much lower will be the reaction rate? Okay, we want to know that because it matters, because that will affect the shelf life. Okay, so then we have what is called the Arrhenius equation. Okay, so in order for us to understand, to relate the rate of reaction and the rate of reaction and the temperature, then we use the, among others, we can use the Arrhenius equation. So this is the Arrhenius equation. Okay, where K is the rate constant. Okay, the rate constant. Okay, the reaction rate constant. Okay, and then A naught is the Arrhenius constant. EA is the activation energy. R is the gas constant, and Q is the temperature. So this is supposed to be T. Okay, P is the temperature. Okay. Okay, so if you were to look at this, okay, and then this, okay, we can change its form, convert it from this form to this one. Okay, convert from that form to this one. Okay, so based on this one, we can see that, okay, this equation, this model relates K to T. Okay, relates K to T. So this is how we relate temperature with the reaction rate, okay, by using Arrhenius equation. Okay, so meaning in general, for chemical reaction, the lower the temperature, so the lower the reaction rate. So reaction rate constant, coefficient or constant. So reaction rate coefficient or reaction rate constant, it is an it indicates how fast that reaction is proceeding. So if you have a larger value of reaction rate constant, so meaning that, okay, the reaction is going at a higher rate as compared to a smaller reaction rate constant. Okay, okay. So now we can relate this to this, and we can improve our understanding. Okay, so that is chemical reaction rate. So when we lower the temperature, then the chemical reaction rate also will slow down. So that will increase will slow down the degradation of the food products, and in doing so, we will be able to extend the shelf life of the food products. Okay, so that is how low temperature affects, okay, produces an extended shelf life for food products. Okay. Okay. Another aspect is respiratory rate. Okay, so respiratory rate, okay, is for fruits and vegetables. Okay, because fruits and vegetables, when we harvest them, okay, we separate them from the mother plants. Okay, the fruits and vegetables are still respiring. Okay, it is still respiring. Okay, it sucks in oxygen and it produces carbon dioxide. Okay, so it is still undergoing respiration. And this respiration is strongly being influenced by temperature, where when temperature is lowered, then the respiratory rate also will be lower. Okay, will be lower. And when that happens, okay, other aspects or processes also will slow down. Okay, for example, the aging process is going to slow down. Okay, reactions will slow down. Okay, so when this happens, then it increases the storage period. Okay, for example, like if you have a certain vegetable, okay, and then you put it in at lower temperature, then it will last longer. It will last longer. Okay. Okay, so this is an example. Okay, so these are the days of post-harvest, and this is the respiration. Okay, so we can see that uh, you can see that, okay, it lowers, it slows down, respiration rate slows down over time. Okay, so if we were to put it at lower temperature, okay, at lower temperature, then the lower the temperature, okay, the lower the respiration rate. Okay. Okay, and the third one, the third factor, okay, is rate of enzymatic reaction. Okay, as I mentioned just now, the enzymatic reaction. Okay, the enzymatic reaction uh, is also one of the main factors of food degradation. Okay, it is so it is similar to chemical reaction rate, where when we lower the temperature, then the enzyme reaction also will slow down. Okay, so when the enzyme reaction rate slows down, then the effect of degradation also will slow down. So meaning the effect will be a longer shelf life. Okay. Okay, so the optimal temperature of most enzymes is 30 to 40 degrees Celsius. Okay, so this is just a general statement. The optimal temperature commonly is between 30 to 40 degree C. So when we reduce it, then the enzymes will not be optimally active. So when that happens, then then we will be able to prolong the shelf life, okay, of the shelf life of the product. Okay, and the relationship between temperature, okay, and also the reaction rate can be represented by the Arrhenius equation. It's similar to that one just now. Okay. Okay, so this is an example. Okay, so this is an example. Okay, so this is Arrhenius plots. Okay, oxidation of glycol. Okay, so this is 1 over T. Okay, this is 1 over T. So when we move to the right, okay, meaning that, okay, the value becomes, okay, the T becomes smaller. Okay, lower T will produce a higher value of this. Okay, so we can see that when T is lowered, okay, the rate of both, okay, rate of both reactions will slow down. Okay, will slow down. Okay, so that is the effect of low temperature. First, it will slow down the chemical reaction rate. Then it will reduce the respiration rate in fruits and vegetables. And also for, in food products, it will slow down the enzymatic, okay, reaction rates. Okay, so all of those. So that is how lower temperature can prolong the shelf life. Okay, and then microbial. What is the effect of low temperature on microbial growth? Okay, so we have, this is what they call as a classical bacterial growth curve. Okay, where you have this is, okay, is the light phase. Okay, and then you have, it is an adjustment phase, okay, where they release a lot of enzymes and fluids, okay, nutrients to grow. Okay, so this is the light phase. So meaning that during this phase, they are acclimatizing themselves to the new surroundings. So there are basically very little growth. Okay, so they secrete out all of these enzymes, fluids, and etc. Okay, so that to make it more comfortable for them to start growing, okay, the bacteria. Okay, and then no slight increase in number of cells. Sorry, number of cells. Okay, so that is the lag phase. Okay, so this is what we call as the lag phase. Okay, and then after it has acclimatized itself, adjusted itself to the new surroundings, okay, then the bacteria will start to grow very fast. Okay, this is what we call as the exponential phase. Okay, so the exponential phase, you can see an increase in the number of cells exponentially. Okay, the number of cells, okay, exponentially. Okay, and then we also have a horizontal phase. So, okay, so this is the exponential phase is the phase where maximum growth happens. Okay, this is where the maximum growth happens. Maximum growth happens. Okay, so exponential phase, there will be a very drastic increase in number of cells. Okay. And then after a while, it will taper off, level off. So that is what we call as a stationary phase. Okay, because when it is over here, it is adjusting itself. Okay, so the environment, the surrounding is not really conducive for cell growth. So after a while, it has acclimatized itself, and now the surrounding is conducive for it, for its growth. Then it will start to grow at a very high speed, high rate. This is what we call as an exponential phase, and then it starts to level off. Okay, because at this point of time, okay, the nutrient has depleted. Okay, the nutrients have depleted, and also it has started to produce toxins that now makes the situation less ideal for growth. Okay, that's why it is leveling off. Okay, and remember, at any point of this, there will be bacteria, microorganisms that will die off, and new bacteria, okay, will grow. Okay, so what we see here is the net effect. Okay, the net effect. Doesn't mean that during this exponential phase, there are no bacterial deaths. There are. Okay, there are. But the bacteria, new bacteria being produced is higher than bacteria dying. Okay, over here it is the same. So it is level off. Okay, and then when the situation is not conducive to to growth, then it will reduce off, taper off. Okay, that is what we call as the death phase. Okay, due to the production of toxins. Okay. So what are the effects of low temperature? The low temperature will slow down the growth rate of the of the bacteria, microorganisms. Okay, for example, okay, here you can see the effect of temperature on growth. Okay, so we can see this is the number of bacteria and this is its time. Okay, so over time the number of bacteria increases. Okay, this is at 35 degree Fahrenheit. Okay. Okay, and then but if we were to increase the temperature, then okay, the growth will be higher similarly. Okay, so when we reduce the temperature, what we will get is, okay, reduce the temperature, so what we will get is a reduced rate of growth on microorganisms. Okay, so and then apart from that, okay, first of all, it reduces the rate of growth. Secondly, it will lengthen the lag phase. The lag phase is the phase over here where the microorganism is just trying to settle down, okay, making its surrounding conducive to its growth. Okay, so when we when we use low temperature preservation, then it will lengthen the lag phase. Okay, for example, like in this one, okay, you have A, exposed food without preservatives and high temperature. Okay, so this one we can see that the growth shot up. Okay. Okay, and then B, cooked foods without preservatives. Okay, so this is for B. Okay, for A, just shoot up like that. This is cooked foods. So when it is cooked, heat will kill the microorganism. So initially it is like this, now it is like this. Okay, so you can see that compared between the two. Okay, because between the two, we can see that the lag phase over here is longer. Okay, compared to this one. There's a longer lag phase. Okay, and then only it shoots up. Okay, and then if you were to look at C, C is raw food but with refrigeration. So this is raw food but with refrigeration, so the lag phase is also extended. Okay, it is longer, extended meaning longer. Okay, meaning that it is taking more time to adjust the surroundings to fit its exponential growth. So meaning that is good, because even though there are microorganisms, but the microorganism cannot get used to the condition to grow. Okay, and then you can see that cooked food, refrigeration, extended lag phase. Okay, so this one is raw food. Now it is cooked food. So that's why we can see that it is at a lower value, because these are the lower value, because this is due to the cooking. So it kills the microorganisms, meaning that it starts at a lower value. But it also extended the lag phase before exponential phase. Okay. Okay. Classification of microorganisms. Okay, so microorganisms, we can find them everywhere, but there are several classifications, okay, which you should know. Okay, for example, we have cyclophiles. It likes cold, common in Canada, northern Russia, all those cold countries. Okay, examples are like Cyclobacter, Morazella, and many others. Okay, those are psychrophiles. Files meaning that likes. Okay, so those are psychrophiles. Bacteria, microorganisms that like low temperature. And then there are psychotrophs. Psychotrophs meaning that it can tolerate, doesn't like it, but it can tolerate. Okay, it is cold resistant, chill temperature. The main cause of refrigeration, food spoilage. Okay, for example, like micrococcus in wheat, enterococcus fruits and vegetables, pathogens, cases of listeria, Yersinia, and E. coli strains, and also Salmonella, among others. Okay, so those are psychotrophs. Okay, because it does not like cold, but it can tolerate it. Okay, meaning that it can grow at that temperature. Okay, and then we also have mesophiles. Mesophiles, moderate temperature, room temperature, as like we are right now. Okay, so these are cases of bacillus, lactobacilli, coliform staphylococcus, shigella. Okay, and then we also have pathogens like Clostridium botulinum and also Campylobacter. Okay, and then on the extreme side, okay, we have thermophiles. Thermophiles, they love high temperature. Okay, likes high temperature, for example, like Bacillus serothermophilus, C. thermosaccharolithium, and also C. putrefaciens. Okay, so these are all examples. Okay, so based on this, now you know that microorganisms, okay, if we want to deal with them, we have to know them, whether they are psychrophiles, psychotrophs, mesophiles, or thermophiles. Okay? Okay, any questions? Okay, so if there are no questions, okay, let's take a 10 minutes break. Okay, toilet break, or you want to grab any snacks, okay, you can do so. And then we'll continue at 12:10. Okay. Okay. Okay, so let's continue. Okay, so we have just discussed about the effect of low temperature. So how does low temperature affects the threat factors of food products? Okay, so first of all, reducing the chemical reaction rate, okay, and then also reducing the respiratory rate, okay, and then also reducing the enzyme reaction rate, okay, also the microbial growth rate, okay, and also not only the rates but also lengthening the light phase, okay, lengthening the light phase, okay, and we also have discussed about the classifications of uh, microorganisms based on temperature. Okay, so you will learn more details about this classification in your microbiology class. Okay, so let's look at chilling and freezing. Okay, let's before that let's go through a brief history of chilling and freezing. Okay, this is an approximate history. It is not, because this is not a history class. Okay, so we are not going to. It doesn't matter if it is not really that accurate. Okay, it is just to give you an overview of what happens. Okay, so the progression from the early times up to now on the advent of refrigeration. Okay, so natural ice. Initially, people used natural ice. Okay, and then they started to have mechanical refrigeration. Okay, sorry, this is supposed to be over here. Okay. Okay. Okay, so people are using natural ice, but they take the ice from the mountains. Okay, because they do not have the ability to make their own ice. And then comes mechanical refrigeration. Okay, so then it started a commercial ice production. So consumers buy ice. Okay, consumers buy ice. Okay, and then another advance is GE and Westinghouse. Okay, they create a home refrigeration unit in the 1940s. Sorry. Okay, but at that time it was still not popular. Home refrigeration, meaning our refrigerators at home. Okay, because it uses ammonia, and ammonia is toxic. Okay, dangerous to our health. It can kill people, so it was not popular. Okay, until DuPont. DuPont is a chemical company. Introduces Freon, so it is a safer refrigeration gas. Okay, then people start home refrigerators starts to become more popular. Okay, so now Freon, we have phased out Freon because it has ozone depleting property. So now we are using something else. Okay, safer one. Okay, so a little bit also about frozen foods. Okay, so 1923, Clarence Birdseye produces among the first frozen food products. Okay, the Poston Company. Okay, so frozen peas, spinach, fruits, and also vegetables. Okay, so those are among the very brief history regarding refrigeration and also frozen foods. Okay. Okay, so let's go to our first method, that is the chilling. Okay, what is chilling? Chilling is definition is the process of lowering the temperature of a product above freezing temperature. So we are lowering the temperature, we are using low temperature methods, but the temperature is still above freezing temperature. So when the temperature is above the freezing point of temperature, the freezing temperature, okay, so water or moisture will still be in the liquid form, liquid phase, okay. It has not changed to the solid phase yet, okay. So it is still in the liquid phase. So when it is in the liquid phase, then it means that it can be used by all the threat factors, okay. It can be used because in order for water to be of benefit, to the threat factors, it has to be in the liquid state. If it is in the solid state, then it cannot be used. It cannot benefit, okay, the threat factors. Okay, for example, chemical reactions. Certain chemical reactions has the presence of water. It needs water. For example, like hydrolysis. Okay, hydrolysis, even by the name, okay, it is hydro means water, lysis means cutting. So it is a cutting process reaction with the presence of water. So it needs the presence of water. So if water is in the solid state, then it cannot be used. Okay, and then we have also discussed about the enzyme reaction. So enzymatic reactions. Okay, majority of enzymatic reactions needs the presence of water. Okay. Okay, microbial growth. Of course, definitely microbial growth. Microbes being a living organism, it needs water for it to grow and multiply. Okay, so all of this, okay, needs water. So when in the liquid form. Okay, so when we are preserving foods using the chilling method, then we are lowering the temperature, but it is still in the liquid form. It is similar to putting our food product in our refrigerator, but at the not so cold, not the freezing part of the refrigerator. So that is the chilling. So it is usually around 4 to 5 degrees Celsius. Okay, so low temperature process without ice formation in the product. So water in liquid form can be used by the microorganisms, enzymes, chemical reactions, etc. Okay, but as we have discussed, what are the effects of low temperature? It reduces growth rate and reduces the rate of chemical reactions and also enzymatic reactions. It also reduces the respiratory, okay, reactions. Okay, major causes of food poisoning are psychotrophs. Okay, so for food products that are being preserved using the chilling method, so the major causes of food poisoning are the psychotrophs. For example, listeria. Psychotrophs, like we have discussed just now, okay, it can withstand low temperature. It does not like it, but it can live and grow at low temperature. Okay, so usually the temperature of chilling, when we talk about chilling, then the temperature usually is 0 to 5. Okay, usually above 0 up to 5 degrees Celsius. And at 0 degrees Celsius, usually most foods will still not be frozen. Okay, because even though 0 degrees C is the freezing point of water, but it is the freezing point of pure water. Okay, water that do not have any solutes in it. Okay, so that is pure water, distilled water. So it will freeze at 0 degrees C. But once we put in, there are solutes, sugar, for example, or salt, for example, or anything that is dissolved in the water, then the water will experience a freezing point depression, meaning that the freezing point will be lower than 0 degrees C. So because foods, okay, most foods, okay, moisture inside the food contains a lot of solids. So most, if not all, foods will freeze only at temperatures below 0 degrees C, not at 0 degrees C. Okay. Okay, so product shelf life is not as long as freezing. So usually around a few days to 1 or 2 weeks only. Okay, So it is what we call as a minimal processing method. Okay. So why is it? Sorry, it has to be why chilling. Okay. Why chilling? Okay. What are the advantages? Okay, we can see that. Okay, product shelf life is not as long, a few days to only 1 or 2 weeks. So why are we still using it? Why is it being used a lot? Okay, especially when we say that for food preservation, what we want is a longer shelf life. Okay, but a few days to 1 or 2 weeks, this is not too long. Okay, so why is it still being used a lot? Okay, so because preservation. Okay, it is a minimal preservation process. Okay, it is a minimal preservation process. Okay, so it is we just prepare the food and then we put it at low temperature, and the temperature doesn't change anything. Okay, or only minimal changes occur for the products. Okay, minimal changes occur for the product. If you were to compare with a more extreme method, that is like freezing. Freezing also low temperature, okay, but below the freezing point of water. So it is more extreme. Okay, we can see the changes. Okay, the product after it has been thawed, bila kita dah nyah beku kan dia, okay, then the properties, the characteristics may not be the same as before it is being frozen. Right? So it is more extreme. Okay, but for chilling, okay, it is very similar. Okay, so not many processes are imposed on the food system. Okay, basically we just prepare the food, put it at low temperature. Compared to that, for example, drying, thermal process, long time, canning. Okay, canning, sorry, actually my notes is in Malay. So I just translated it. Okay, so there will still be some words in Malay. Okay, for example, in canning, so it involves the melting, okay, potting, okay, involves canning, the canned food itself. So it is more extreme. For example, for canning, retorting is meaning that we heat it. That you will learn about it after in the second half of the semester. Retort means that we heat it above the boiling point of water. Boiling point of water, pure water is 100 degrees C, but for retorting, a minimum temperature of 212. Okay, sorry, 121 degrees C. Okay, 121 degrees Celsius of heating. Okay, is required. Okay, so it is above the boiling point of water. Okay, so that is how extreme it is. Okay. Okay, and then also minimal, because it is a minimal preservation process, its effects on quality characteristics also is minimal. Okay, it's minimal. Okay, for example, the color. Okay, if you were to do blanching before canning, then there is a loss of color, texture, heat process. We can see the sardines in the can, even the bones becomes soft. Okay, so there is very high heat. Okay, and then if you were to use, like we have learned previously, okay, using chemicals, then there is the problem of a sourish taste if you were to use acids or vinegar. Okay, but for chili, it doesn't change. Okay, or very little change. Okay, so that's why it is preferred. It is being used. And then consumer also likes the perception of fresh. Okay, because fresh is being perceived as being more healthy, more good, okay, more nutritious. So when we are preserving using chili, then there's not much change, not much different compared to the original food products. Okay, so people prefer that because it is more fresh, okay, to them. Okay. Okay, So that is a little bit about chilling. Okay, so now we will go into different types of food products. Okay, so we will discuss about meat, poultry, and then seafood and fruits and vegetables. Okay. Okay, so let's go to meat first. Okay, so meat meaning, for example, uh, uh, mutton, uh, and then also we have uh, buffalo meat, and we also have cattle meat. Okay, cow's meat. Okay, so these are all in the same category. Okay, so when we want to determine how to preserve it, then we have to understand how it degrades. Okay, remember the uh, figure just now. Okay, so you need to understand our products. Okay, so what happens when meat decomposes or degrades? Okay, so we look at the postmortem chemistry. Postmortem meaning that after death. Okay, postmortem. Okay, so after death, okay, then what happens is that glycolysis will happen, where glycogen will be converted into lactic acid. Before death, okay, the energy is through the food, okay, and then some also to glycogen, but now there is no source of food, okay, because death has already occurred. So what will happen is that the body, okay, will still the animal, the physiology of the animal will still try to maintain the condition before death. Okay, so it needs energy, so there will be a breakdown of glycogen, and that will result in lactic acid. Okay, and then because there is no more homeostasis, okay, the protein will undergo degradation, meaning that it will lose biological activity and also solubility, meaning that the structure has changed. Okay, and also loss of water binding. Okay, loss of water binding is also important because when there is water, then the meat will become juicier. Okay, it will become juicier and more tender. Okay, and then also it will occur. What will occur is proteolysis. Okay, proteolysis. Proteo means protein, lysis means breakdown. Okay, cutting. So it is the breakdown of proteins. Okay, basically. Okay, so proteolysis enzyme or proteolytic enzymes. Okay, we have proteases. Those are proteolytic enzymes. Okay, it will break down the collagen and also the elastin. That will affect the level of tenderness. Okay, so meats. Okay, in the animal protein or meat. Okay, it will exist in different forms. Okay, muscle proteins, and then they have what they call as connective tissues, and among them are like collagen and elastin. So when there is collagen, the meat tends to become less tender. Okay, less tender, but that is not preferred. Okay, to by the consumers. The consumers prefer tender meats. Okay, so uh, proteolysis will break down the collagen and then will change the level of tenderness. Okay, and then there are also microbial activities, and then low temperature reduces the reaction rate. Okay, so why do meat spoils? Okay, first factor is enzymes. Okay, so limited proteolysis is encouraged. Okay, like we discussed just now, proteolytic enzymes. Okay, so it will break down the protein, but it is encouraged up to a certain degree, because when there is proteolysis happening, then it improves the tenderness of the meat. Okay, so but too much is also not desirable. So that is why usually meat, most of this practice is in the Western countries, where after slaughtering they will uh, uh, put the carcass, okay, the carcass, basically binatang tu yang telah disembelih, okay, they'll put the carcass at low temperature for the enzymes to act, proteolytic enzymes to act on the collagen, elastin on the proteins, okay, of the carcass, so that it will become more tender. However, in Malaysia, we don't practice that because usually after slaughtering, we will straight away cut up the meats, okay, to sell. Okay, so that is the first spoilage. Second is physical. Okay, physical factors, for example, like loss of water, loss of maturity, reduction of yield weights, and also loss of red color. Okay, so uh, uh, loss of water. Water is important because for raw meat, okay, it constitutes of about up to 70% of the weight. Okay, so it is important because for the meat industry, when they sell based on weight. So when there is loss of water, meaning that there is a loss of weight, which is not desirable because their profit will also decrease. Okay, and then loss of red color. Okay, loss of red color. If when meat spoils, then the red color will be lost. We will talk about that in more detail later about the reactions that occur. But we can see that when meat spoils, then the red color that is preferred by consumer, that is an indicator to them uh, uh, of freshness, because the consumers perceive that red meat, if the meat is red in color, then it is more fresh. Okay. Okay, a question, is there any difference between protein breakdown and protein degradation? No, I just use both intermittently, okay, interchangeably. So protein breakdown or protein degradation still refers to the same process, okay? Okay, and then another factor, okay, is biochemistry. Biochemistry, for example, in meat there is fat, and when fat is exposed to oxygen, there will be oxidation. Oxidation will result in rancidity, ketengikan. Okay, rasa tengik, bau tengik. Okay, rancid odor, rancid tastes. Okay, and then also when it also degrades, okay, due to the meat having sulfur containing acid aminos, then there will be a putrid odor. Putrid ni dia macam pengit and a very very strong and sharp smell. It is undesirable. Okay. Okay, and then another causes of meat spoilage, okay, is the microbiology. Of course, this is important, okay, because post-mortem the animal is dead, so there is no immunity. Okay, so it is exposed to various treatments. Okay, for example, source internal endogenous, okay, microbes from inside the animal itself, from intestines, blood. Okay, so when it is exposed to the source, so it will contaminate and grow. Okay, and then also external sources, microbes from external sources, for example, like the air, premises. Premises means the building. Okay, knives, workers, etc. Okay, so the greater the ratio of surface area to the volume, the higher the contamination rates. Okay. In physical spoilage, what does loss of maturity? Oh, sorry. Loss. Oh, sorry. This is not loss of maturity. Okay, thank you. This is moisture, actually. Okay. Okay, thank you, Suguna, for pointing that out. Okay, loss of water. Okay, loss of moisture. Okay, it will result in the reduction of yield weight. Okay. 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 In normal circumstances, okay, most of the time, most mesophilic are the major microorganisms, such as micrococcus, bacillus. Okay, because the type of microorganisms that is mostly growing in any system is based on where the food system usually is. Okay, if it is at low temperature, then psychotrophs or psychophiles. If it is at normal temperature, okay, medium temperature, it is the mesophiles. If it is the high temperature, it will be the thermophiles. Okay. Okay, at chill temperature, okay, Pseudomonas, Lactobacillus, okay, will be more noticeable. Okay. Okay, and also during degradation, okay, or spoilage, it produce undesirable aromatic compounds. Okay, so we'll talk about that later. Okay, so meat spoilage scenario. So what happens? Okay, so when meat spoils, okay, we can see what we see is there will be a production of mucus, there will be discoloration, foul odor, okay, being produced. Okay, I think all of us has this experience, okay, previously. Okay, and then meat is broken down by collagenase activity. Collagenase is also a protease, okay, we mentioned just now, but it is more specific. Its action is more specific on collagen. That is, protease is more general. It acted on proteins, so that is why it is called a protease. So a collagenase is a type of protease because it is a subset of protease. Okay, it hydrolyzes the connective tissues. Okay, and then there is gas production, hydrogen, carbon dioxide, ammonia, because ammonia is part of the amino acid, which is a part of the protein. So there will be, so when there is a breakdown, it will produce ammonia. That's why spoiling meat, okay, has a foul odor. Okay, one of it is being caused by the production of ammonia. Okay, and then there is color change, like we have discussed previously. Okay, caused by oxidation, okay, of myoglobin to methmyoglobin. Okay, so when we have this, okay, myoglobin is a pigment. Okay, it's a pigment that is inside the meat, and it is purplish in color. It is purplish in color. But when it is exposed to oxygen over here, exposed to oxygen, it will bind. It will bind with oxygen to produce oxymyoglobin. That will produce the red color. Okay, so that will produce the red color that we see of meats, of fresh meats. Okay, red color. But this is not a chemical reaction. It is a binding reaction, and it can happen both ways. So if we have a meat, okay, and then it is exposed to oxygen, it will turn from purplish to red. Okay, the same meat, when we suck out the oxygen or we excrete the oxygen, then it will change from red to purplish. Okay, so it is a two-way process, a two-way reaction. Okay, because, and there is no change in the chemical structure. Okay, because it is more of a physical. I mean, like it does involves chemical reactions, but it is not a permanent one. Okay, so it is a two-way reaction. However, if that same meat, the myoglobin, okay, gets oxidized because of spoilage, it gets oxidized, okay, then it will change from myoglobin to methmyoglobin. Okay, from myoglobin to methmyoglobin. That is from purple to brown. Okay, from purple to brown. And this oxidation, okay, it is a chemical reaction, and it is not reversible. It is not a two-way reaction. It is just a one-way reaction. It is not reversible. Okay. Okay, so that is about myoglobin. Okay, or myoglobin also can combine with hydrogen sulfide, H2S. Okay, so this is from protein breakdown, because certain amino acids like cysteine, okay, it has a sulfur component. okay, a sulfur component. So when the amino acids breaks down, it produces hydrogen sulfide. Okay, so when this hydrogen sulfide, okay, combines with myoglobin, it will form sulf-myoglobin that is green in color. So that is why I think if any of you have any of you could have some experience. Okay, if there is spoiling meat, sometimes certain parts of it will turn greenish in color. Okay, so that is because of the reaction between myoglobin with hydrogen sulfide to form sulf-myoglobin. Okay, and then putrid odor. Okay, putrid odor. Okay, very undesirable odor. Okay, will result from anaerobic action on amino acids. Okay, sour smell results from the formation of lactic acids. Okay, lactic acid among others from the glycolysis, glycogen converted to lactic acid. Okay, and then there will be also aerobic degradation. Okay, the most notable is Pseudomonas. It will usually use the most freely available source of energy, that is the carbohydrates that is outside, okay, on the surface. Okay, that will usually that not much degradation can be seen, and then after that it will start to use the amino acids. Okay, will break down the protein, produce ammonia. Okay, and also reduces the pH, increases the pH, sorry. Okay, and also produces amines and also sulfides. So all of these are aromatic. Aromatic meaning that it contributes to the aroma. It can be smelled by our nose, detected by our nose. Okay. Okay, so ratio of surface area to significant volume, it is important. The higher, okay, the ratio of surface to volume, okay, the more the risk of contamination. Okay, the more the possibility of contamination. Okay. 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 I think we can finish this a little bit. Okay, let's finish this. Okay, and then we can go to poultry for next week. Okay. Okay, so how do we preserve meats? Okay, by chilling. Okay, first and foremost, this is the most important aspect of any preservation method. Okay, please remember this. Okay, it is not the method of preservation, but it is the reduction of initial microbial counts. Regardless of any preservation method, this is the most important step. Okay, have to remember this. Okay, where? Okay, doesn't matter how sophisticated and how efficient that method of preservation, but if the initial microbial count is not being controlled, then it will reduce the efficiency of that preservation method. Okay, so that is why in any preservation method, the first and foremost step is to reduce the initial microbial counts. Okay, because this is a burden to the efficiency of the preservation method. Okay, so we have to reduce the initial microbial counts. Okay, so initial microbial count, okay, the lower the degradation rate, the higher the efficiency of the preservation method. Okay, preservation method or preservation step. Okay, so sources of contamination, as we have discussed, the skin tones, etc., premises, etc. Okay, so what do we do in order to achieve this? Have to take care of personal hygiene, okay, sanitation, good manufacturing processes, okay, all of this. Okay, and all of this you will learn in more detail. Okay, the food safety system, etc. in, I think, maybe year 2 or year 3. Okay, so this is just enough for you to understand that you have to take care of personal hygiene, sanitation, and there is a program that is being named as a good GMP, good manufacturing practices. What is inside that program, you will learn later. Okay. Okay, and then storage temperature, of course, it is chilling, so between 0 and 5 degrees C. Okay, low temperature control is important. We do not want the temperature to shoot above 5 degrees C. Okay, temperature abuse. Temperature abuse means that the temperature is not controlled and it goes beyond 5 degrees C. Okay, so that is temperature abuse. Okay, will result in the reduction of storage period, or that is a security or safety risk. Okay, I should put it as safety. Okay, safety risk. Okay. Okay, and then also needs to be packaged, okay, to reduce water loss from it, because this is fresh meat, okay, and it contains a lot of water, and we have discussed just now, when it is fresh meat, then it is being sold based on its weight. So the loss of water means the loss of weight, means the loss of profit for the business. Okay, so it needs to be packaged, and also when there is a lot of water loss, then it will result in the quality of the meat, because the meat will become drier. Okay, it becomes dry. Okay, less juicy. Okay, so it needs to be packaged. Okay, to reduce water loss. Okay, how do we package it? Okay, there are several methods. Okay, the first is just normal packaging. Okay, I put it as aerated packaging. Okay, meaning that the packages has air inside it. Okay, the normal type of, we put the product inside a package and then we seal it. That's all. Okay, so meaning that inside the air, inside the package, the composition of air inside the package is similar to the composition of air outside of the package. Okay, so meaning that it has oxygen. So when there is oxygen, it allows aerobic microorganisms to grow. Okay, sorry, aerobic microorganisms, meaning that microorganisms that can grow in the presence of oxygen. It may need oxygen. Aerobic need oxygen, or it can withstand oxygen, either one. Okay, so the details you will learn in your microbiology class. They have aerobic, anaerobic, where it grow in conditions that do not have oxygen, and then it also have a classification that is known as a facultative anaerobic. Okay, it can withstand. Okay, okay, so aerobic microorganisms such as Pseudomonas, so that can grow. Okay, oxidation. Okay, we talk about oxidation. Okay, because oxidation is important, because meat usually contains fats or lipids that can react with oxygen to produce rancid odor and also rancid tastes. Okay, so that is undesirable. So that's why it is important. Okay, and then when there is the presence of oxygen, we have discussed also just now, myoglobin will bind with oxygen to produce oxymyoglobin, that is the red color, which is preferred by the consumers. Okay, so all of this will happen in a normal packaging. Okay, where there is oxygen. Okay, but the setback is there is growth of aerobic microorganisms. So how do we deal with it? One option is to use a vacuum packaging. Okay, so vacuum packaging meaning that we put the meat inside a package, then we suck out the air from the package. Okay, so block when there is no air, meaning there is no oxygen, it will block the growth of aerobic microorganisms, right? Okay, so it will last longer. So that will be significant is for, but other microorganisms that is not aerobic, okay, that it can still grow. For example, lactobacillus, okay, still grow. Okay, however, even though it looks nice, but the setback of active packaging is because of the pressure. Because when we suck out the air, then the atmospheric pressure will press on the meats. So there will be what we call as a syneresis, where fluid will be excreted out from the meats. Okay, first of all, visually, the appearance is not nice. Okay, because food products, we want it to look nice, desirable, so that consumers will buy. Okay, so when you see a piece of meat and then there are fluids everywhere, so it's not really desirable. Okay, visually. Okay, and also this is much more important. This one is only for the appearance, but what is more important is this one, because when water is excreted out, then now it is, you can see that it will exist in puddles. Dia bertakung di sana sini. Okay, so when it is in puddles, meaning that it can, microorganisms can readily use it because now it is in a free form. Inside the meat, it is bound by the microstructure of the meat, but now it is in free form, so microorganisms will grow. So it will create a micro environment for the growth of microorganisms, which is not preferable. Okay, red color will disappear. Okay, because of no oxygen. Okay, it will convert back from oxymyoglobin to myoglobin, but the good thing is that it will block oxidation. Okay. Lastly, okay, another method is gas packaging. Okay, so gas packaging is like this one. Okay, aerobic microorganism, a problem. This one, no problem of aerobic microorganism, but you lose the red color, which is desirable. So gas packaging is like in between. Okay, it uses CO2. Okay, it uses CO2. Okay, and also this one. Okay, it will create pressure. Okay, syneresis. Okay, so it will create syneresis. Okay, so gas packaging is in between. Okay, it uses CO2, so no pressure on the meat. Okay, no pressure on the meat, but still be able to block the growth of aerobic microorganisms. Okay, so no CO, no O2, so still no red color. Okay, but blocks oxidation. So that is the plus point. Okay. However, the minuses are among the most important. Okay. Okay. So, so the minus is it is more costly because this one uses just air. This one you only need an equipment, but this one you need an equipment and CO2. So it costs more. Okay, so that is about chilling of meats and types of packaging. Okay, so we have covered the post-mortem chemistry. We have also covered the factors, causes of meat spoilage. Okay, and also the scenario, what happens during spoilage of meat. Okay, based on our understanding of that, then we can decide on the how to preserve meats. Okay, by chilling. Okay, and then also the different types of packaging that can be used. Okay, any question? I think we'll stop there and we'll talk about poultry the next time. Okay, any questions?
No, doctor.
Yeah. Okay. Okay, if no, then we'll stop here. Okay, and we'll continue next time. Okay, so thank you all.
Thank you, doctor.
Thank you, doctor.
Thank you, bye.
Thank you,
Thank you,
doctor.
doctor.
Thank you,
Thank you,
doctor.
doctor.
Thank you, doctor.
Thank you, doctor. Doctor for attendance.
Thank you, doctor.
Doctor, what about attendance?